externally facing system components. Another point to consider here would be virtualization. Can any of the environments be virtualized? What sort of hardware and space would be required? This involves setting up your test environment within one or more master host servers, in turn potentially saving on hardware, setup and support costs. A common mistake here, however, is to underestimate the space required for your test environment, leading to major issues during the course of a project when you need to scale up. I was recently on a project where the integration environment was due to transfer to UAT use, and it was found that there was insufficient storage space allocated to the customer database, which obviously prevented UAT because they had a far greater need for more customers than integration, so the environment had to be essentially rebuilt, causing significant delays. Moving on to who requires access to the test environments. This is primarily driven by security and need. There needs to be a degree of test independence across all the environments being used. This means that access to the test environments is usually limited to the project staff who need it. Access requirements should be defined and agreed at a pre-planning stage. Support staff, for example, require access to all the environments that have particular maintenance needs on a daily and weekly basis. Change and release management staff will require access to all environments to ensure that QA and procedural standards are being adhered to. Developers usually only need access to development, and sometimes potentially in conjunction with the release management team they may also need access to some sort of staging or pre-integration environment to allow for initial releases of code to be carried out without endangering any of your main test environments. Testers and analysts will require access to all the specified test environments, with the exception of development. The consideration here should be at what level. Can the testing being carried out be done as super admin users? Do they need to have users set up? Security testing, for example, may need user permissions setting up, which can be a big support overhead if not addressed early. Offshore testing access should also be considered, as this may have an impact on your support schedule, as to take advantage of the obvious extended working day and offshore testers starting earlier or later than GMT. It's obviously an extra support implication that the guys would have to bring the systems up earlier than the UK normal working day, which again could be a problem if not addressed early. How many environments do you need? Testing independence, environment integrity, effective hardware utilisation and minimal cost wastage should be your key concerns here. Development environments carry much less data, for example, than UAT environments, because the need to check data is not a primary concern for developers, whilst it is a primary concern for UAT testers and potentially performance testers. There's an assumption with UAT that all systems are as production, because obviously by its nature you're carrying out UAT, whereas in development, developers are used to their environment always changing. Data loads, although volumes may differ, should be similar across all your environments to allow for effective fault finding and resolution between each of the environments. Access to test environments should be restricted. Developers, for example, should not be granted access to any test environment. It's important, however, that they can see the data that's been used to raise the issue in the first place. This exchange is predominantly important between integration testers and developers. Similarly, during integration testing, it's essential to verify all your external links both in and out of your new system. It's therefore important that you have as much of this support and architecture in place as possible. This may also be of interest to security testers if you have any on your project, as all potential weak points of the system should essentially be tested. How do I minimise downtime? The key here is to control your test environment using a variety of tools and methods. Configuration management and release management are two of the main ways to ensure you maintain a high degree of environmental integrity. This does not always require investing substantial sums of money in configuration and or change release management systems, or indeed retraining your staff to use them. In some instances it can be achieved by simply changing your approach and implementing a new attitude of control. For example, efficient administration is important to alleviate any unnecessary risk. User creation and administration should be treated similarly to development and only carried out by trained staff. Not to do so is to create a potential risk, which is as damaging as allowing bad code into your test environment, as obviously if your testers have no users to log in, your system's essentially down, so whether it be a technical issue issue or a user issue, your system is still not working. Availability should also be closely monitored to spot any daily trends or hotspots at an early stage, which would allow for fixes and tweaks to your schedule to be carried out as early as you can in your life cycle. Although not pertinent to all projects, everything we've mentioned here could be virtualised, which in turn reduces risk again. This involves capture and release scripts from multiple project areas, including configuration information, which is then documented via an intranet page. Once it's tagged with a version name, this produces a virtual build, which can then be used by all the test teams to access each of the test environments. With this example environment structure, we see our potential policing points. We have developers feeding the development test environment using a degree of configuration management. This in turn feeds the staging environment using release management. Once the code's been verified as stable, it's then eligible for deployment